2.3 is on functions and relations. We will mostly focus on functions. That's what we use to define a lot of things in mathematics. So this is presented a little different than the book. I like to define a function first, and then the relation is just a concept we'll look at as we go. So write this definition down. So a function is a correspondence between a first set A, it doesn't matter what variable is there, but we'll call it A, and that is called a domain, and a second set we'll call it B, called a range, such that each element of the domain corresponds to exactly one, and that's the critical part there, exactly one element of the range. Okay, I'll read it again. So a function is a correspondence between a first set A, called a domain, and a second set B, called a range, such that, and when you say such that, it's like the rest needs to follow or be true, such that each element of the domain corresponds to exactly one, I'll highlight that, corresponds to exactly one element of the range. So we'll go through some examples and talk about what's a function and what is not a function. Okay. So for examples, remember the EG means for example. So we'll do two sets. So we call this our first set. I'll duplicate that to here. And so this is my set A, and this is my set B. And let's do that. I'm going to make a number of these. Let's duplicate that, bring this down here, put this over here. Okay. So we have these different cases. So over here we'll write A, B, and C. So those are members or elements of the set A. We'll do the same thing here, A, B, C. And here we'll say just 1, 2. And down here we'll have 1, 2, 3. And so this is the simplest way to define a correspondence. And basically you go from one set to the other like with an arrow. So we say A corresponds to 1. So suppose we have this, and then let's see if it's a function or not. B corresponds to 2, C corresponds to 2. Okay, and then we have, let's suppose A corresponds to 1, B corresponds to 2, B corresponds to 3, and C corresponds to 3. All right, so which one of these is a function, which is not a function? So the part that's most critical is we write each element of the domain. So this, we're going to call these, that's our domain. We'll go ahead and call that the domain, just like above, where A is the domain. So each element here corresponds to exactly one over here. So does A correspond to exactly one thing? Yes. Does B correspond to exactly one thing? Yes. Does C correspond to exactly one thing? Yes. Now, B and C happen to correspond to the same thing. That's okay. But what you can't have is basically the one below, right? So this is yes, a function. Yes, a function. Now, down here, as I was basically saying, A corresponds to exactly one. Does B correspond to exactly one thing? And of course it doesn't. B is corresponding to two different things. So that is the problem. That means it's not a function. Oops. Okay, so not a function. So it fails right here. This one right here. This is what is the failure, is that B is corresponding to two different things here. Okay, let's do some more examples. What if I had something like this? So we'll set up a wording kind of concepts. I'm trying to get across the concept before we dive into just math stuff. So domain, it will define the correspondence. And then the range is a set. So the correspondence is what we're going to define, and the domain and range will be a set. So the one I like to give, and this one, maybe I should change it, but let's suppose we're all sitting together and we can talk to each other. But so the domain will be this math class. So this math class. Okay, and then let's suppose you're sitting in seats, right? So this is seat numbers. It could be like any math class. It doesn't have to be this math class. We just suppose. And then the range would be a set of numbers. It would be a set of integers, actually. So a set of integers. So does that define so picture a class of all of us sitting down in the class, all of us, and then you have a seat number as a correspondence. So you're sitting in a seat number. And so 1, 2, 3, 4, whatever they might be defined to be. And so the range would be the set of numbers, set of integers, actually, because you don't have half of a desk or something. So when would this be a function or not? So you're picturing a bunch of desks, basically, right? And then there's you're labeling these. So all these people are sitting here. And so what situation would occur where it would not be a function? And basically, think of it like this. Suppose you're using up two desks when you're like you have, you're maybe sitting here, but you put these together, and you have books spread across both desks. Does that define a function? And in fact, it does, because it's basically you, and you're corresponding to. No, sorry, messed it up. So if you're using more than one desk, then it would not be a function. Now, if you have two people, you and another person, I'll just say other, and you're corresponding to that desk. If this person is corresponding to the same desk, that would be appropriate, of course, in a classroom, but that would still be a function if you have two people using the same desk. that's still a function because you're corresponding to just one thing. But if you're using two desks, then that's not a function because you're corresponding to more than one of those desks. Okay, so think about that, how that would work. Okay, so I write this one so have you picture what's going on, not necessarily just memorize some definition. Okay, here's another one that I will use, and I never really know, and I can't know because this is a video, but still think of this one. So the same domain, and let's suppose correspondence are siblings, your brothers and sisters that you have. The range would be a set of people. And before I ask this question, I never know if this is a function or not, because you have each one of you, and you may or may not have siblings. So if you don't have a sibling, then you're a single child basically. Then there wouldn't be any correspondence, but you're just sitting there. However, for the correspondence, what would make this work? What would not make this work to be a function? So think about it. And so the real question is, at least one of us has more than one sibling. Okay, so if that's true, do any of you have more than one sibling? If that's true, then this is not a function. Okay, then not a function. And so that's really the question. And I have one sibling. I have one brother, so that would be my correspondence. So I would not know this question unless I ask you. So we can assume at least one of you has more than one sibling, and therefore it would not be a function. All right. Moving on. Next to function notation and more mathematical concepts or examples of functions. So this is on function notation. Okay, so let's write down some concepts that we need to talk about. Maybe I've seen a couple times. Suppose you have y equal to 2x squared minus 1. And then the other way of writing that is the f of x notation. That's your function notation. So f of x equal to 2x squared minus 1. So in this notation, we say y is the value of the function. Of the function y equals f of x. We say x is the independent variable. So x, this variable here, whatever you're putting into the function, that's when you say f of something, and it could be any variable in there, t, w. So x is the, what we say, independent variable. X is in the domain of the function. Okay, then y is the dependent variable. Y is the dependent. And y is in the range. So y is in the range of the correspondence. All right, so let's look at other. So we write f of x, but it can be other. We use other notations. The next one we often use is g of x. We use h of x. That kind of thing. We can use a different variable. We can use like f of t or w of t or any variable you want. But it's that parenthesis that then defines your independent variable on the inside, and then your dependent is whatever this is going to equal. So if it equals y, then that's your dependent variable. If it equals, say, like, I don't know, k, then that's your dependent variable. It depends on what's going inside the function. All right, let's put this into our correspondence notation. So draw us a couple circles again, like this. Looks good right there. That's fine. Duplicate that, put it over here. And so this is our domain. This is our range. And so x, this often refers to the x-axis or the horizontal axis. Then you have some sort of function name. So we call that's your f or g or h or something. And that's your range. So we often use y, where we say f of x equals your y. So your f of x is over here, and that's the value of the function. This would be the y-axis, or usually the vertical axis. And so in our notation, let's go. I'm going to go ahead and move this over and draw an axis and talk about that as well. So referring to what I don't know how that zoomed in. Referring to what I had, so here's your x, here's your y. We often call this then the values here are the domain. And the values along the y are the range. So that's how we normally do it. So your independent is usually horizontal, your dependent is your vertical, like that. Okay. Next, we will look at this. At the next video, we will look at the graphs of functions and graphs of relations. And I'll go ahead and split this one up because this is getting a little longer. So far, that's what we have of definitions, and we're starting to build all these concepts of functions.